Hey everyone, welcome back to another math video. In today's video, we are going to be talking about how to find the greatest common factor for polynomials and how to factor it out too. So let's go ahead and let's get started. So first things first, we're going to be working on finding the greatest common factor for each of these groups, okay? So here I have two monomials, alright? And remember that the greatest common factor is the biggest thing, term, or factor that can multiply into both of these. What is the largest factor? So for example, I see 8y raised to the power of 3 and 28y here. I know that 2 can go into both of these. 2 times 4y cubed can give me 8y to the power of 3. And 2 times 14y can give me 28y. But that's not the biggest one, okay? We are always going to aim for what is the largest thing that can multiply into both of these things, or however many things we're working with, monomials or polynomials, okay? So the first thing, I usually break it down into two steps. The first thing I do is I look at the numbers, 8 and 28. What is the largest number that can multiply into 8 and 28? And hopefully you're able to realize, you can try different numbers. Usually I just start with the lowest number, so I think of 8, and I go over what are the numbers that can go into 8 that can also go into 28. So 1 can go into 8 and 28, 2 can go into 8 and 28, 3 can't, 4 can go into 8 and 28, and really then it just leaves 8. But 8 cannot go into 28. So the largest number that I could think of was 4. So I'm going to go ahead and put 4 down. I know that that is the first part of my greatest common factor. When it comes to monomials and polynomials though, the next thing we have to ask ourselves, is there any variables that can be included in my greatest common factor? And the first thing you got to ask yourself is, well, is y, or is the variable that I'm working with, included in all of the polynomials here, or all the monomials? So both of these terms have a y. So that tells me off the bat that I am going to have a y in my greatest common factor. But the second thing I got to look at is which one's the smallest, because whichever one's the smallest is going to tell me how many y's I can actually include. So they both have a y, but this is a y raised to the power of 1. So between 3 and 1, one of them has y raised to the power of 3, one of them has y raised to the power of 1. So because 1's the smallest, I know that my greatest common factor can only have one y, okay? So that would actually mean that 4y is the greatest common factor for this problem. So 4y is my greatest common factor. Let's go ahead and let's look at one that's a little bit more complicated. Although there's more terms and there's more variables, the steps don't change. First thing I'm going to do is I'm going to look at the number that's in front of all these monomials. So I have a 9, a 15, and a 21. What's the biggest thing that can go into all of these? Again, I'm going to start with 9. I know 1 can go into 9. I know 3 can go into 9. And that's pretty much it. So of those two numbers, is there any one of those two that can go into all of them? Well, 3 can go into 15 and 3 can go into 21. That's already bigger than 1. 1 can go into anything always. So 3 is going to be the base of my greatest common factor. Now I look at the letters and I ask myself, do they all have the same letters or variables? Okay, so they all have an A and they also all have a B. So I know that they both have an A and a B, but now we got to ask ourselves, how many of each? So we look at the exponents. What is the smallest a? Well, the smallest a belongs to the second term. That's right there, which is just 1a. So I'm going to leave my a like that. I don't need to write an exponent since it's just 1. B's, what's the smallest b? Well, the smallest b is this one, b squared. The other two terms have a b raised to the power of 3. So I'm actually going to put b squared. And 3ab squared is my greatest common factor. And voila! So now what we're going to do is, this is the first step in factoring. we're going to go ahead and factor out a polynomial. But the reason why we covered this first is because we need to know how to find the greatest common factor. Okay, so here it asks us to factor out from the greatest common factor from each polynomial. So first let's go ahead and let's find out what is the greatest common factor. So for this problem, my greatest common factor, again, we look at the numbers. What's the biggest number that can go into 12 and 15? Okay, hopefully you can realize that that number is going to be 3. And then I ask myself, do they both have variables? Yes, they both have an x. Since they both have an x, I can take one and put it in my greatest common factor. And I can only do one because that is the smallest one. So 3x is my greatest common factor here. So what I'm trying to do is I want to see 3x can multiply by what and get me 12x squared minus 15x. Or better yet, we can divide this by 3x to find out what needs to go in those parentheses. Okay, depending on how your mind works, you're going to have to decide which one's best for you. A lot of times I like to set it up this way: 3x times something equals 12x squared. So 3x times what will get me 12x squared? Well, I know 3 times 4 can give me that 12. And x times x can give me that x squared. So I know that this first piece needs to be 4x. 3x times 4x, yep, that's 12x squared. Now 3x times what will get me a negative 15x. And for this one, really, the x is there. The x didn't change. But how do I turn a 3 into a negative 15? Well, I got to multiply by negative 5. So, negative 5. And this is what happens when we factor out 3x from 12x squared minus 15x. That is exactly what I needed to see. I could double check this by distributing, and you'd see that you get 12x squared minus 15x. Okay, let's go ahead and let's look at another example problem. Here I have negative 4y raised to the 4th power plus 6y squared minus 14y. Again, the first thing you're going to want to do is you're going to want to factor out or find your greatest common factor. What is our greatest common factor? So what number do negative 4, 6, and negative 14 have in common? What is the one thing that can go into all of these? Alright, you can work it out and you'll figure out that the biggest number that can go into all 3 of these is negative 2 or positive 2. Up to you. I'm going to go ahead and go with positive 2. Do they all have a y? They sure do. But what's the smallest y? Well, that is, this one. So I can only use one y in my greatest common factor. So I want to factor out a 2y from that whole thing. And you can set it up like we did that last example. Another way you could do this is to simply just think of the end result. 2y multiplied by what can get me this term? Well, negative 2y raised to the power of 3. 2y times what can get me a 6y squared? Well, 2 times 3 can give me the 6, and y times y will change it to a y squared. 2y times what will get me a negative 14y? Well, I just need to figure out how to get negative 14. That would be a negative 7. And that's how I factor using the greatest common factor. So hopefully now you feel confident in being able to find the greatest common factor of a monomial or some polynomials, and also that you can factor out the greatest common factor from a set of polynomials. We're going to be getting into some different kind of factoring, but this is just the start. So definitely rewatch it if you need to, pause, play, ask questions in the comments. I'll be here to answer them. As always, I just want to thank you for watching, and I hope you continue to learn some math.